In this video, we'll talk about the details behind why charged objects, positive, negative, and neutral. You may already know this, and it's kind of common sense, but we'll do it once quickly. In a previous video, we started with a neutral sock and a neutral rug. That sock was neutral, and so was the rug. We rubbed the sock back and forth on the rug like this. And we saw that negative electrons, they moved like this. They moved from the rug to the sock, didn't they? Now, that leaves a positively charged rug, because before there were an equal number of positives and negatives here, weren't there? But we lost 3, leaving more positives than negative, a net charge larger than 0, and thus a positive object, meaning the rug. And of course, the sock before we started had an equal number of positives and negatives, and it gained 3 negatives, didn't it? Meaning it ended up being negative. So when these electrons moved, they left a positive object behind, the rug, and created a negative object, the sock. Now we know the negative charges that move our electrons. Electrons are very light, easy to remove from atoms. They're the things that move when we have negative particles, negative charges moving. The question is, what are the positive charges? Well, looking at the atom, the positive particle here is a proton, isn't it? It's positive. Here are the electrons on the outside. The neutrons are neutral. So the positive charges are usually protons. Electrons are negative, protons positive. So let's look at this neutral sock here. It has an equal number of negatives and positives. Net charge is 0, and that's neutral. That means an equal number of electrons and protons, protons being the positive. So there's a neutral sock. If I'm talking about a negative sock, then we have more electrons, don't we? So we have 3 extra ones here. So we have 3 extra electrons. That means that the net charge is less than 0. That means it's negative. I'm going to use the rug as the third one because the rug ended up being positive, as you recall. The electrons had moved, so we had more protons than electrons. See, we have 4 to 1. Net charge is larger than 0, and that's a positive one. So it comes down to how many electrons and how many protons we have usually. And to finish it off, one more example. We're going to use this gal's gorgeous blonde hair. We have 2 protons, don't we? So we have 2 positive plus 2, but we have 4 negative electrons minus 4. The net charge is negative 2, meaning her hair is negative. Here's your video code, neutral. Next, what have we got? Let's see, I have 4 protons, 1, 2, 3, 4, plus 4, only 3 electrons, 3 negatives, so we get a positive charge, net charge of 1, don't we? A positive object, the hair. And finally, I bet we're going to have neutral, aren't we? How many protons? 1, 2, 3, 4. And how many electrons? 1, 2, 3, 4. Positive 4, negative 4. Net charge is 0, and we have neutral. So that's what it comes down to. When we're talking about charged objects, we talk about the number of protons and electrons, usually positive and negative, and whichever one has more determines the charge of the object. Bye.